All right, this is footage for the kickoff trailer. Hey everybody, I'm Tyler and I'm here with my colleague Matt Brown, and we wanted to introduce a new video series that we're doing that talks specifically about multi-fiber connectors. Now, multi-fiber connectors have been around for a long time, and I wanted to bring Matt in here mainly because he's been there since the beginning. So Matt, you've got a perspective on this that is very rich in context and depth here. Tell us a little bit about the connectors and what people really need to know and what they can expect out of this video series.
So the MT ferrule technology has been around since the 80s. The MPO connector, or something, there's a trademark MTP connector, pretty much the same thing, have been around since the early 90s. They've been in networks extensively ever since. So they're a new topic to people, but they've been out there in the networks for a very long time. They've been in a place where they aren't seen. They've either been in the backplane of transmission equipment, where a line card would connect to an optical backplane, or really in very large volumes behind the panel in an indoor enterprise or data center type installation, where we have a high density trunk that's being turned from that has MPOs on it, that's being turned into an LC or Sam Charlie patch panel. There's that transition cassette. So they've been around for a long time. We're starting to see them more and more, and they're a hot topic now because they're really transitioning out from behind that panel. Yeah. And technicians in data centers, in central offices, in head ends, all over the place are now being confronted with, what's this new port? It doesn't look like an LC. It doesn't look like a Sam Charlie. What is this connector? It's got these pins on it.
Yeah.
There's a lot that goes on with the MPO that's very, very different than the traditional Sam Charlie and LC stuff. And it's growing really fast. So it's come out from behind the panel or from the backplane into the regular population where everyone has to deal with it. And that's happening right as that hockey stick of growth that it's been experiencing is becoming really large volumes. So it's pretty much everywhere. It's even not in an MPO connector format. It's even in the outside plant, in fiber to the home, access networks, in mobility, tower builds. So that multi-fiber technology as an MPO or another hardened connector type is has been showing up in the past few years, kind of everywhere in our networks.
Perfect. Yeah, so over the next couple episodes, we'll talk about some of those challenges, whether it be dealing with contamination or, like you said, polarity, the pins, no pins, the alignment, applications, and all that kind of stuff. So glad to have you. Look forward to going through these over the next couple of videos with you. Thanks a lot. All right. This is multi-fiber trailer. This is the second take, a little bit more concise. Hey everybody, I'm Tyler from Viavi Solutions, and I'm here with my colleague Matt Brown, and we wanted to talk a little bit about multi-fiber connectivity. Now, it's something that's been around for obviously a very long time, but Matt has really been around for the ride since the very beginning. So I wanted to bring you in, Matt, to talk a little bit about this and give some more depth to our viewers about what these connectors are, how they're different, and what they should be keeping in mind as they're starting to experience these in the field.
Sure. So almost from the beginning, not really from the absolute beginning, but MPO has been around for a long time. It is a multi-fiber connector. So what is an MPO? It's a connector that has many fibers on that single connector, as opposed to a Sam Charlie, which has one fiber on it, or an LC, which has one fiber on it. Even if you duplex them and gang them, there's still just one fiber on each of those connectors. So an MPO is a connector that has many fibers mounted on a single ferrule. It's been around for a very long time. It's been in our networks for a very long time, but it's been in a place where we don't have to deal with it, or a regular technician or it doesn't have to touch it and manage it on a daily basis, because it's been behind a panel, providing rapid connectivity of dense trunk cables and converting them into an LC form factor, or elsewhere on a backplane where we don't see it. Now, with a number of trends that are happening, we're really seeing that that the MPO is starting to come out from behind the panel, and it is on the panel, and you have to deal with it. So the technician is out there going, "What is this adapter? What is this big rectangular thing? It's not a Sam Charlie, it's not an LC." And then he gets a jumper and it's got pins on it. what is that? And how am I supposed to put it in there? It's got this key on it. There's just a lot of things that are very different about the technology. It's a very good technology. It's a very powerful technology, but it has some things that are different that we have to deal with. And so that's what we should be talking about in the next series of videos.
Yeah, perfect. Glad to have you here, Matt. We're over the next couple of videos, we'll be talking about all these things that Matt just talked about. So look forward to having you with us on these. Thanks a lot. Okay. All right, this is Dealing with Contamination MPO. Take 2. Hey, everybody. I'm Tyler.
Matt.
We're with Viavi Solutions, and in this episode, we wanted to take a closer look specifically about the challenges of contamination with MPO.
Yeah, so there are a lot of things that come into play, right? So the kind of first and most obvious is that with a traditional connector, a SAM Charlie or an LC, you have this ceramic split sleeve that's in the adapter, and when you walk up to a panel and you pull that dust cap off, you can see that there's a little tiny hole. It's a 1.25 millimeter hole that the LC connector is going to go into, the ferrule is going to go into. If you look at an MPO on a panel, it is a giant rectangle, right? It is a very big area. So there's just way more access and way more area for contamination to get into the interface. And right, even if you just look at the two things in your hand, the little tiny LC ferrule, which a lot of people get confused, is like, is that the fiber? No, that's a ceramic ferrule that holds the fiber. On the MPO, you've got this black rectangular ferrule that holds many fibers. So there's just a lot more surface area here for contamination to get into place, and a lot more access on the bulkhead side for contamination to get in there. The other thing that's going on is that there is one fiber on here. There's a small 1.25 millimeter fiber at the center of that 125 micron fiber in the center of that ferrule. There are 12 or 16 or 24 fibers on that ferrule. So probabilities are power functions. So if we say that there's 90% chance, there's a 10% chance that that fiber is dirty, which means there's a 90% chance that it's clean. Well, if we have 12 of them in a row, you take that 90% chance it's good to the 12th power. That's how you add up the probabilities, and you get something like 30% chance that that all the fibers are clean together. That all those fibers together are clean is way, way more unlikely than this one fiber by itself is clean. And add those things up, and what you get to is that they're contaminated. I mean, we know from personal experience, you go out into an installed base and the connector's been in the panel for a long time, there's a high likelihood it's going to be contaminated. With MPO, it's almost a certainty that that thing's going to be contaminated. What is that? Why do we care? It goes back to the inspect before connect model that we have. Debris and contamination on the end face mess up the transmission. It's true for an LC and a SAM Charlie. It's more true for an MPO or an MTP connector, because just like on the fiber on an LC, if there's dirt or debris or contamination in the core, it's going to mess up the transmission. Same on an MTP. If there's dirt or debris outside the core and on the fiber or on the ferrule, it may not get in the light path, but it can stop the two things from coming into physical contact. And we need those fibers to touch each other. We need those two fibers to physically come into contact, and there's no air, there's no daylight. With an MPO, you've got all these fibers in this array, and they're all coming together. And if one of them gets blocked, if one of them is prevented from physically contacting, the neighboring fibers can also be prevented from physically contacting. We know it. Like we have a theory on it, a model on it, and then we've demonstrated it, we've tested it. We know that contamination over here prevents physical contact on several neighboring fibers. So way more likely to be contaminated because there's just more area. Way more probable that 12 things are contaminated. 12 things are much more likely to have one of them contaminated than one. And if the contamination exists, it's going to impact neighboring things. So it's this huge issue. What do you do about it? You inspect it. I mean, you see what's going on. You clean it, right? You absolutely have to have a good cleaning solution, a designed for fiber optic connectivity cleaning solution. Been around for a while. We used to have Kim wipes and IPA, right? And that was our cleaning solutions, not so hot. Or people used to clean with not designed for optics. And bad cleaning solutions will scratch or damage the end face. So use something that's designed to do the job, and you have to verify it.
Inspect it again.
You have to. I mean, it's what Reagan said, trust but verify, right? I trust the cleaning tool, but I have to verify that it did its job. Especially with all these fibers, there's just so much going on there that we often, even with very good cleaning solutions, find that a first clean, something gets moved, something gets left behind, and you just have to check and see that it's clean. Once you see it's good, you're safe to connect. That connection is going to be good for the lifetime, for as long as it's plugged together, right? The good news with optics is once you put them together, they stay good until you mess with them.
Yeah. Appreciate it, Matt. Thanks again.
Cheers.
For more information, you can reach us at viavisolutions.com/MPO. Thanks a lot. All right. This is a polarity episode of MPO. This is the first take. Hey, everybody. I'm Tyler.
Matt?
We're with Viavi Solutions, and in this episode, we're taking a closer look at some of the challenges with polarity for multi-fiber connectors. Matt, tell us a little bit. We've heard this term a lot with polarity, even with single fiber connectors. Tell us a little bit more about what that's all about.
Yeah, so polarity is essentially making sure that the transmitter on one end of a link is connected to the receiver on the other end of the link, and the transmitter on the far end is connected to the receiver on this end. If my transmitter is talking to that transmitter, there's not a link, right? The link isn't up. Nobody's receiving the data. So it does exist in duplex connectivity. In a duplex LC is usually used to connect one SFP to another SFP because one's talking in one direction and one on the other. Those can get messed up, right? A lot of people would know from personal experience that you can get those two lines flipped, and it's relatively easy to fix. Can be troublesome, but you can find it and you can fix it. With MPO, it just gets really complicated because I don't have one fiber on this connector and one fiber on this connector. I've got 12 or 8 or 24 fibers locked into position on a connector, and I can't change them. So with MPO, I may be putting different traffic down each pair on that 12 fiber. That 12 fiber MPO may be 6 separate channels, or it may be one that's talking on these 4 fibers and listening on these 4 fibers. So it can be used in a bunch of different ways, and maintaining that transmit connected to receiver, receivers connected to transmit each of the transmit fibers connected to the right receivers on the other side, and vice versa, becomes really complex with MPO.
So you don't necessarily just try to make sure that you got the right person talking aligned up with a general listener. You need the right talker and the right listener.
And there are many different. Again, you can have many different channels. One channel, you can be using the MPO for. It's complex. So we standardized this a bunch of years ago. So you might hear about these Type A, Type B, Type C polarity. Yeah. So what that is a defined methodology of building the link. MPO is even more complex because not only is it where are all the fibers, it's the MPO has a key that controls how the fibers are connected from one connector to another connector. So if you've got this key up on this side, key down on this side connector, this MPO comes in like this MPO comes in upside down, this fiber gets connected, pinky fiber gets connected to index fiber, right? If I'm key up to key up, pinky fiber talks to pinky fiber. None of them are wrong. They all have solid design behind them to assure that the link connects the right fiber on this end to the right fiber on the far end. But if you mix up, but they all use different components, and if you mix the components up, you will scramble the signals going off in all kind of different directions. So it's very easy to get wrong, and you can't figure it out. So so if we look at a duplex LC, talking to SFPs, you're connected through, you're trying to plug them up, it's not working. You call your buddy on the other end, he puts a VFL on his transmit side, you look and you go, oh, it's coming out on my transmit. I've got my connectors flipped over. So you can kind of flip your LCs around, plug them in, you've fixed it.
That's easy, yeah.
You can't fix it on MPO because you can't move the fibers. You can't even figure out what's going on because you shine a light on the MPO on this side, it's just coming out of all the fibers on this side.
Glowing.
So you can't like look and say, oh, you're on fiber number 2. You can't tell. Vendors out there sell systems that are really heavily designed to go in and work right on the first time. And so on an initial build, when you're building it out, you're using all the same vendor stuff, you're using all the right part numbers. Another part is you got to get the bill of materials for the build right. You can easily, if you mess up on what you're ordering when you put this link together, unfortunately, I got one of the wrong cables in place and it flipped everything over. So ordering wrong can impact it, but usually that initial build goes fine. Now somebody comes to turn up services and add patch cords. Are they using the right patch cord for the system? Or you've got you had a legacy system that was MPO, that had MPO trunks,
an upgrade scenario,
and went to LCs, and now you're saying, well, I'm going to go parallel optics. I'm going to rip out the module. I'm going to put in a panel. I got my MPOs, and I'm going to connect through to the QSFP. That's a legacy built system. I don't know when that trunk was put in, or those trunks were put in years ago. Now, are you getting the right patch cords? So there's a lot of ways for it to go wrong.
You brought up something really interesting, and this is a scenario where we're seeing MPO used a lot. It was an investment that they made several years ago in an architecture that was for an easy plug-and-play rollout, and now they're saying, hey, I can still use this multi-fiber architecture as I'm migrating, say, up from 10 gig to 40 gig. But the challenge now is, like you just described, hey, I don't know what kind of polarity I have.
We'll talk about pins in another video series. That comes into play. So again, MPO is just very complex. So the takeaway is that you need to test it, right? If you're building on an MPO link, you need to verify that that link has its correct polarity. It's in 568. I mean, 568, since this duplex connectivity said, one of the things you're verifying with this test is loss, length, and polarity, that you're routed correctly. So you got to test it when you're building a link. You should be able, if you're going to troubleshoot one of these links, you should have a tool that can identify one line on the MPO from another line or fiber on the MPO. And so there are very few tools out there that do that, right? You need a light source and a power meter that have MPO ports on them and can individually determine, I'm sending you power on line 2, I'm receiving that power on line 4, oh, that's wrong. Or, oh, that's what I expect, that's how this thing is mapped out and built. So you need an MPO designed test tool that can verify that polarity if you're going to know what's going on. You can't do it visually. You can't do it with a VFL. You're kind of in the dark.
Yeah, makes sense. Well, thanks again, Matt. Until next time, I'm Tyler.
And Matt.
And you can find out more information at viavisolutions.com/MPO. Thanks for watching. All right, this is the aligning MPO pinned versus unpinned video, take 1. And this will go into some other footage.
Sorry, how about we just have these in front of us?
Yeah.
Is that weird? Or can we just put these things right here? And we can go pick them up. What do you think?
Yeah, that's fine.
Yep.
All right.
That's good. Let me just have you do the lead in
Yep.
again and
Aligning MPO, pin versus unpins, first take. Hey everybody, I'm Tyler.
And Matt.
We're from Viavi Solutions, and in this episode, we wanted to take a closer look at the challenges with MPO alignment. This is a different thing than what we see with simplex connectors. Can you tell us a little bit more?
Yeah, so a simplex connector aligns itself, or the two connectors in a simplex connection, if you hold that up, are aligned by aligning that cylinder to that cylinder using a ceramic sleeve, right? So that sleeve grips around those two cylinders and aligns the core. On a multi-fiber connector, I've got 12 fibers in a line or 24 fibers in 2 lines, and I don't have that. I don't have that capability. So multi-fiber connectors align themselves by one connector having guide pins, and the other connector not having guide pins, but having holes that the guide pins slide into. So guide pins and guide holes. It's an effective way of aligning those 12 fibers, right? You get pretty solid loss performance out of it. The problem is you can't connect a pinned connector to a pinned connector, and you can't connect an unpinned connector to an unpinned connector. So that really puts you in a bind. MPOs aren't identical. Sam Charlies are effectively, both ends are identical. It doesn't matter. With an MPO, it matters. If you try to connect a pinned, if you try to connect a pinned MPO into a port that already has a pinned MPO on it, it's not going to latch. The two pins are going to bind. You might bend them. You could damage the system. If you try to plug an unpinned MPO into a port that has an unpinned on the other side, it will latch and it will connect. Unfortunately, those fibers will physically mate. The end faces of those fibers will come into each other and compress, and the thing isn't constrained, so it's going to slip. And those glass surfaces are grinding on each other and could damage it, and certainly won't get loss performance, and it'll be a very lossy connection. So in any case, neither of those provide a functional connection. You have to have a pinned connector going to an unpinned connector.
So let's cut to the challenge then of, so we know no pin to pin, no unpinned to unpinned, but now we've got situations in a test environment where I may have my test equipment that either has pins or doesn't have pins, but then I need to verify that reference and the scenario might be different. This has created a number of challenges.
Oh, it is a challenge, and then every time you touch it, that you experience the challenge maybe in a different way. So if you're upgrading, so step one in building and designing your systems, you have to order the right gear. You have to order the right combination of pinned and unpinned connectivity, or you're going to get a bunch of product out on your floor and you're going to be trying to plug them up and it doesn't go, and now you got to reorder. If you're upgrading something, that you may expected that MPO to have pins, but it doesn't have pins, and now you've got all the wrong gear. For us testing, we have to provide launch leads, and we provide our test equipment is all pinned. So the test equipment itself has pins on the ports. So we provide an unpinned to unpinned jumper. But what if I'm trying to? So that's fine if I'm plugging into a pinned port. But what if I'm trying to plug into an unpinned thing? Well, now I need an unpinned to a pinned jumper. So how many the jumpers can get lost? These jumpers are expensive. These are relatively affordable. MPO cables are pretty expensive. So it's a problem. So you can maybe use conversion cables, buy more cables. What we've done, or what we're doing, is latching on to a solution that has recently hit the market. Right. So the good news on this is a couple companies have come out with solutions where the MPO can be changed from pinned to unpinned. You can put pins into an unpinned MPO or remove them safely. I should say, it's not effective or possible to remove these pins with a pair of pliers or any other methodology you may try and grab onto the pin. You will damage and wreck the connector. It is not possible to stick pins into this unpinned MPO and have it function as a pinned MPO. So there is no field conversion on regular MPO connectivity. Our friends at US Connect have a solution where they have a new connector, the MTP Pro, that lets you add or remove pins in the field. The Panduit, our friends from Panduit, also have a solution that's proprietary to them. But I think we can expect that US Connect MTP Pro to hit the market. It's hit the market already, but we can expect to start seeing it. And you're certainly going to start seeing it in our test kits because, as you just alluded to before, specifically with test, you've got a piece of equipment that you're plugging into a bunch of different things. You're trying to test different links or channels or what have you. So you find the need to change what that jumper is a lot more on test because you're moving it around throughout the infrastructure. So in the future, in the near future, we're going to be deploying those MTP Pros in our test gear so that you can change that to be whatever pinned or unpinned you need. And you're going to go see these guys at IBYC, I think, and maybe cut some footage.
Let's just cut here.
Okay.
Sorry.
Did we totally run? Yeah.
Yeah.
Well, okay. So where did we? That I think is an important safety announcement. So it needs to be more concise.
What happened was it started going into this is. I really want to set this up to be an introduction to there's some challenges with this. This isn't educating people. Yeah. And I want to quick jump over to that video. This is a setup of them giving it quickly and also
introduce the technology.
Yep.
The difference, right?
Yep.
Then the requirement that they go together, why the two ways don't work.
Yep.
And then
there's some new solutions on the market.
And then we see it particularly as a problem for test because our thing is going out and introducing things. And so we are taking advantage of some of the solutions that are coming out of the market.
Exactly. And let's leave it at that. Okay. Well, the other thing to remember is this is intended to be a video that could last a longer stretch of time. So references to like, hey, you're going to see this person at IBYC or whatever. That
okay. Well, I didn't know how to hand over. I expected you to try and jump in, and you weren't jumping in. So it's like.
Yeah, I need some
breathing. Take the ball.
I need some breathing room there. Take a breath every once in a while that I can talk.
Right. Okay.
So
we run about 5 minutes. You guys didn't hit the impact section there, but the rule of thumb is bullpen.
I saw we missed that, and I kind of couldn't. I think it's useful. It's useful information. I saw I missed it, and I couldn't get back around to it. Right. I can address that when I just talk about. These are pinned. They have to go together. The rule of thumb is this.
Yes.
But that's not always true.
I almost feel like we could cover a lot of this stuff in like less than a minute. We could breeze through. I almost think we don't need to beleaguer the, hey, pins, don't do pins to pins, don't do unpinned to unpinned. We could briefly talk about that. That's a 10-second thing. Don't do that. Then how do you overcome that? You know.
Yeah. Okay. We'll be. So let's just try and speed it up and cut it free. So again, this.
All right. This is MPO alignment, pinned and unpinned, take 2. Hey everybody, I'm Tyler.
And Matt.
We're from Viavi Solutions, and in this episode, we're talking about the challenges of alignment for multi-fiber connectors. Now, this is different than a typical simplex fiber.
Yeah, right. So if you pick that up, the simplex simplex connectors align by aligning this cylinder on this side to the cylinder on the other side using a split sleeve in the adapter. The MPO connector has nothing in the adapter. It's just a big hole. The 2 MPOs, we align all the fibers on the MPO by using guide pins and guide holes. So one MPO connector has pins, and those pins go into the holes on the other MPO connector. So unlike the simplex connector, where the 2 ends are identical and they work that way, the MPO connector, the 2 mating connectors have to be fundamentally different. You can't plug a pinned into an unpinned. It won't latch, it won't go. You can't plug an unpinned into an unpinned. You could actually successfully plug it in, but you won't get good losses, right? It won't align the fibers and you won't get good losses. And you could probably damage the fibers because when those 2 fibers mate, nothing's constraining them and they can slip and grind on each other. Mm-hmm. So you're stuck. If you have, if you're doing an install and you're trying to plug a QSFP into your panel with a jumper, and that panel's got pins and that QSFP's got pins, you need an unpinned to an unpinned jumper. If you've got a pinned to unpinned jumper, you can't make your connection, right?
So this has introduced a number of challenges on the test side as well.
Yeah, precisely. It's a challenge because the test tool is going to have to touch a number of different kinds of ports. So you may be testing a pinned, you may be testing an unpinned. What do you do about that if you've only got one kind of jumper? The other is validating your reference. So when we reference out a loss tester, we take the light source and we plug it into the power meter and we zero that out, right? Mm-hmm. Later on, as we're working, we like to validate that reference. That is, we've got a patch cord on this side and that launch lead over here. We connect them and we check the loss, and it should be like a really low number, like a 0.1 or 0.2 dB. We know that reference is still good. Well, with MPO, if I've got 2 unpinned connectors as my launch and receive lead, I can't connect them and reference it out. So I have to put a 3rd connector in there that's pinned on both sides. It's confusing to the user. So there's good news, though. So there's some recent products that have hit the market. Our friends at Panduit have had a proprietary solution out for a while. Our friends at US Connect have the MTP Pro that they've recently released that is going to let us switch out the pinned and unpinned state in the field. So that new MTP Pro is a connector where it is safe with tooling that you can remove the pins or add pins into the connector. So therefore, if you're stuck, you can't connect it right, you have the ability to change it.
Yeah, sounds good. Hey, for more information, you can visit us online at viavisolutions.com/MPO. Thanks again. All right. This is MPO alignment, pinned and unpinned, take 3. Hey, everybody, I'm Tyler.
And Matt.
And we're from Viavi Solutions. And in this episode, we're talking specifically about the challenges of alignment for MPO connectors. Now, with a typical simplex fiber, it's pretty simple.
Right. That cylinder gets mated to the other cylinder or connected to the other cylinder on the other side in a split sleeve, right? So these 2 things get lined up and aligned. With MPO, we've got this array of fibers, and we don't have a split sleeve, right? We have nothing but a wide open channel in the adapter. So how do MPOs do it? Well, one MPO has to have pins, and the other MPO has to not have pins. So the guide pins on the one MPO go into the guide holes on the other MPO, and that aligns the 12 fibers. So if you've got a pinned connector and you're trying to plug it into a port that has pins in it, it's not going to work. The thing won't latch in. If you've got an unpinned and you try and connect it to an unpinned, it'll go in, but you'll get terrible losses and you'll probably damage the fibers. So you better have ordered the right gear or you're not going to be able to plug your link up. And they can't be changed in the field, right? You're stuck with this. You ordered this. This is what you've got.
So this introduces a lot of challenges when it comes to testing.
For sure. One is that my tester, my MPO tester, needs to be able to plug into either pinned ports or unpinned ports and test whatever I needed to test. The other is in reference verification. So we're using duplex LCs or Sam Charlie's on a simplex or duplex tester. I'm used to verifying that reference condition by taking my light source with its lead and plugging it into my power meter with its lead and just checking that.
Simple.
Just baseline. How's my baseline? Okay, I'm good. With the MPO, if I've got two unpinned MPOs, I can't unpinned here. I can't verify that reference. So now I have to put a third cable in the place, a pin-to-pin cable, and I can verify the reference, but it's a little more complex, and people aren't used to doing it. So it tends to confuse a guy who's used to used to validating his reference on a simplex tester.
But there's some new solutions on the market now.
Yeah,
right?
Good news. I said you can't change them in the field, and you can't with these legacy guys. Our friends at Panduit have a solution, the Pan MTP, that can its pins can come in and out. It can change itself. Our friends at US Connect have a solution where they have a new connector that you can add pins or remove pins safely in the field. So that is good news that now we've got the ability to change it. But mostly you're going to have to pay attention. The big message is pay attention and look at what you're plugging into each other, because you can damage your connectivity.
Yeah, perfect. Hey, thanks again, Matt. Appreciate it. For more information, you can find information online at viavisolutions.com/MPO. Thanks for watching. Okay, this is the trailer intro. As a manufacturer of fiber optic test equipment, we're always hearing about the latest innovations and applications in fiber networking technologies. One of the biggest topics we've been hearing about in recent years has been multi-fiber connectivity, like MPO. Now, these have grown in many ways over the years. Although they've been behind the scenes in applications for several years, they're starting to become more prolific in the forefront, being used in fiber to the home, fiber to the antenna, enterprise and data center applications. And so as a result of that, people are starting to utilize them more and more. I'd like to stop there.
You didn't say your name or Viavi?
Yep, yeah. I almost don't know if I don't want to do that, and that was intentional.
Okay.
What I'm thinking for this one is, instead of the hi, I'm Troy McClure kind of thing, is I'll just start talking, and then just on the on-screen text we can add something. Yeah.
Okay. Kind of shoot your chair like an inch that way. As you move, you cover the eye and back and forth. So
Okay.
that's perfect right there. Okay. There we are.
All right. Trailer take 2. As a manufacturer of fiber optic test equipment, we're always hearing about the latest innovations and applications in fiber optical. I want to do that again. All right. Take 3. As a manufacturer of fiber optic test equipment, we're always hearing about the latest innovations and applications in optical networking technology. In recent years, one of the most popular things of discussion has been multi-fiber connectivity, like MPO. Now, these have been around for several years, more in behind-the-scenes applications, but recently new technologies and growth have driven the adoption of these into newer places in fiber to the home, fiber to the antenna, enterprise and data center applications, and more. And they bring several advantages, and which is why many people are utilizing them, but at the same time, the multi-fiber connector has a lot of differences from the single fiber connector that can be pitfalls and traps if you're not careful and you don't know what you're getting into. We want to be able to help you with that. So we're introducing a series of educational videos that I'll be interviewing a couple of experts talking about. I want to stop right there. Dang it.
It's feeling really good.
Yeah.
You're very natural on camera.
Thanks. I got to my last section, and I started going in a way I didn't want to go.
Gotcha.
This might be where I could try to do it in one take, but if possible, I might need to do a second thing.
Yep, we could totally splice it.
All right. Let me try the second half of that just on its own.
Okay.
And then from there I can try a full take.
Okay.
Well, multi-fiber connectors, I should say the lead in. Okay, this is take 3, the second half of the trailer. While multi-fiber connectors have several advantages over a single fiber connector, there's also some additional details and challenges that can be, there's a number of differences. Dang it. Okay. All right. While these multi-fiber connectors have several benefits over a traditional single fiber connector, there's also some differences that can be challenging to new, dang it, that can introduce challenges. Number of differences that can introduce new challenges for technicians. All right. Second half, take 4. While multi-fiber connectors have several benefits over a single fiber connector, they also have some differences that can introduce new challenges for technicians. We want to help you overcome those challenges. In order to do this, we're rolling out a short video series that goes over some of these details to help you understand MPO connectivity better. Join me as I interview various people who can talk in greater detail about these things. You can find us online at viavisolutions.com/MPO. Intro, second half, take 4 or 5. All right. While these connectors have several advantages over a traditional single fiber connector, there's also some details that can introduce new challenges. We want to help you overcome those challenges. To do this, we're introducing a new video series where I talk with various people who can provide expertise and insight into the world of multi-fiber connectivity. You can stay aware of these videos and other resources by visiting us online at viavisolutions.com/MPO. Thanks for watching. All right, now I'll see if I can do the whole thing.
I mean, worst case scenario, we'll have just a crossfade in there. And
Yeah. And there may even be some opportunities.
We could, we'd take a shot at doing one take.
Okay, yeah. This might provide opportunities to do some cutaway to some B-roll of a close-up of an MPO or something like that,
Sure.
which gives me, I wouldn't mind actually doing one where I just literally read that script and then you could borrow from that as well.
Right.
For B-roll kind of things or whatever. All right, here we go.
Take 6.
Okay. MPO multi-fiber trailer, take 6. As a manufacturer of fiber optic connectivity, we're always hearing about the latest innovations and applications in optical networking. One of the latest topics that we've been hearing about in recent years has been multi-fiber connectivity, like MPO. Now, these have been around for several years, but have become more prolific in recent years because of some of the advantages that they bring in networks as they grow. We're seeing this show up in enterprise, data center, fiber to the home, fiber to the antenna, and they're all bringing new benefits that are being utilized, but they're also introducing new challenges as well. While they have several benefits, there's some differences that you need to be aware of comparing a multi-fiber versus a single fiber. We want to help you understand these differences and overcome the challenges that they bring. To do this, we're rolling out a series of short videos where I talk with some people who can provide expertise and insight into the world of MPO connectivity. Join us as we walk through this series over the next, I want to see, you can stay aware of these videos and other resources by visiting us online at viavisolutions.com/MPO. Thanks for watching. I had a little thing in there, but that could probably be spliced out.
Yeah. It was spliced. That would be a good spot to have spliced to B-roll and then it'd come back to you just for that last little
Okay.
bit of information. I mean, I definitely will want to be on you for the,
Okay.
check out these resources.
I wouldn't mind doing one now where I'm literally sitting here and I just read this.
Yeah, that'd be great. I'm
okay.
going to go ahead and have the cameras rolling just so I can tell what's what as I go to edit, but
Okay.
let's do that. And the other thing, I'm going to bring this around a little further than even.
Okay. Is that going to mess with the audio in case you splice this in, or does it matter?
It shouldn't, but just, let's keep it more where it
Okay.
was.
All right.
What I'll do set all of the gains to be even, and so if the mic placement varies, it'll
Gotcha.
level it back out. So, okay.
All right. This is trailer take 7, just reading the script. As a manufacturer of fiber test equipment, we're always hearing about the latest innovations and applications of optical networking technologies. One of the most popular things in recent years has been multi-fiber connectivity, like MPO. Although it's been around for many years, less visible in networks, new applications and architectures are relying on multi-fiber connectivity. Although it's been, I want to do it from the top, sorry. Script, readout, take 8. As a manufacturer of fiber test equipment, we're always hearing about the latest innovations and applications in optical networking technologies. One of the most popular things in recent years has been multi-fiber connectivity, like MPO. Although it's been around for many years, less visible in networks, new applications and architectures are relying on multi-fiber connectivity as they expand the capacity of their networks to support growing demand. We're seeing this throughout the world, from enterprise and data centers, service providers, FTTH, FTTA, and more. While these connectors have several benefits and advantages over typical single-fiber connectors, there are also a number of differences that introduce new challenges for technicians. To help you overcome these challenges, we want to help you understand multi-fiber connectors better. Join me for a series of short videos where I talk with a few people that provide expertise and insight into the world of multi-fiber connectivity. You can stay aware of new videos and get additional resources online at viavisolutions.com/MPO. Thanks for watching. All right, this is a MPO video testing interview, or testing, I'll say. Take 1. All right, hi everybody, I'm Tyler from Viavi Solutions, and in this episode, I'm talking with Ed Gassel. He's our product line manager for many of our fiber optic test equipment, and he also oversees many of our MPO test instruments. And so I wanted to have some time to talk with him a little bit about the different portfolio that we have and what testing is used and when. So Ed, thanks for being on with us.
Thanks, Tyler.
So tell us a little bit when it comes to MPO testing. I know it's been around for a long time, but a lot of folks who are getting into this are asking, okay, what do I need? What kind of test equipment do I need for MPO?
And MPO testing is not that much different than regular duplex fiber testing in the sense of what tests need to be performed. Obviously, the testers are somewhat different. So for the tests that you need to perform, you've got your straight-on inspection of the fiber end faces, and of course it's typically a 12 fiber ferrule that you have to inspect. You've got your Tier 1 or basic certification, which is your loss length and polarity. And you also have your Tier 2 or your enhanced testing, which is performing OTDR tests so that you can really see each individual event in that fiber link. So that's really, it's the exact same that you would see for duplex testing. It's just that your tools have to be different because you've got a different fiber connector, being that MPO connector.
Great, yeah. So when we've talked a lot, obviously, about fiber inspection and other episodes and such, but I want to ask a little bit more about when it comes to, you talked about length loss and polarity, differentiating when to use a typical MPO to MPO test versus maybe, I know there's applications where MPO is a subset of a greater length. Can you talk a little bit more about when you'd need to use direct MPO testing versus others?
Yes, and so MPO really has been in networks for quite some time, and it's been used as a backbone or a trunk. And when you have that backbone or a trunk, then you'll typically have something like a cassette to break down into individual LCs. And that still exists, and that will get you up, in today's world with multi-mode, will get you up to 10 gig. If you start to go beyond 10 gig, then you start to need to have different types of connectors out at the end. Yeah, so that's, this is your cassette. You've got your 24 fibers coming in at the back through MPO, and these need to be inspected, but then your test is done with a classic OLTS by testing each of the individual LC drops. So in this case, you really don't need to test the trunk assembly. If you do need to troubleshoot it, that's where an OTDR would come into play, and then you can look to find out where a specific fault is. But typically with those trunk assemblies, your issue is your connections that you have, the MPO connections. So then when things start to get different is where you're running at, especially with multi-mode, 40 and 100 gig, and there are systems like PSM4 for single mode that also run what I would call native MPO right into the equipment, whether it's a switch, a router, server type of thing. And for that, then you need to start having native MPO interfaces on your test equipment, which allow you to test those links and channels. And so that's what in this case, the MPO-LX does, is your basic or Tier 1 certification, your loss, length, and polarity. And it's done really much the same way that you would do with an OLTS on LC links, is you do a set reference, you set a limit, and then you connect up to your system that you're testing, you perform the test, you get pass-fail, except you're doing a pass-fail on 12 fibers now instead of 2.
Gotcha. Okay, so very similar behavior. It's still an optical loss test set.
Exactly.
Now, and you said this is more prevalent when you get into that 40 gig, 100 gig with QSFPs and such.
With QSFPs, where you've got that direct QSFP or MPO connection into your switch and servers, that's where you need to be. Your link itself, instead of being a duplex LC, your link is an MPO, typically a 12-fiber MPO. And that's why you need to test that link with native MPO testing. Or you can test the channel as well, disconnect from the QSFP plugged into the switch, server, router, whatever, and then test the channel.
Okay.
Yeah.
Now, you had briefly mentioned the Tier 2 or enhanced testing as well, finding out more information. Can you talk a little bit more about some of the new technologies with being able to test an MPO individual lanes with an OTDR?
So with our 4000 platform, we have a switch module for it, and so your OTDR is still a simplex connection, but the simplex connection goes to the switch, and the switch gives you that 12-fiber MPO out. And because the switch module and the OTDR module are both on the same device, it's really automated. So you say what you want to test. I want to test all 12 fibers. You hit start, and the OTDR tests fiber number 1, the switch switches to fiber number 2, tests fiber number 2, and so on. So you just start it, step back, and let it go through all 12 fibers by stepping through with the switch.
And again, like any OTDR, that gives you the benefit of seeing each individual event through that entire.
Correct, yes. And with modern OTDRs, certainly the 4000, is that you're then seeing a schematic view so that you see what the events are and which events have a problem with it, instead of having to read a squiggly line on the screen.
That's perfect.
Yeah.
Well, hey, thanks again for joining us, Ed. You also recently wrote a white paper that goes into greater depth on this.
Yes.
For more information and to get that white paper that Ed wrote, you can visit us online at viavisolutions.com/MPO. Thanks for watching.